All right. Hi, everybody. Today we're looking at absolute value inequalities. So I've got an example here. Solve this inequality, right, less than or equal to, and write the solution set using interval notation. Okay, so I just copied the problem down here. I'm going to start by doing the sort of, easy, straightforward sort of cleaning up stuff that helps us kind of see what we're looking at. So the absolute value is the part that I need to sort of be most careful about how I deal with. But these other factors out here, this, multiplying by 2 and adding 1, those I can easily move to the other side of the inequality without really changing anything, and help me get a clearer view of how to deal with the absolute value. So I'm going to start by isolating the absolute value. To do that, I need to subtract 1 from both sides, which gives me 6, and then divide by 2. Okay, so what I'm really interested in is where the absolute value of x minus 3 is less than or equal to 3. This is a good place to pause and think. I don't necessarily mean the video, but you can do that too. But we're looking at an absolute value. What we know about absolute value, whether we think about it as a function or an operation that you do on numbers, is that when you take the absolute value of something, you get back a result that is non-negative, meaning it's either 0 or bigger. So the thing I want to think about at this point before I go any further is whether the question I'm asking makes sense, if it has sort of particular solutions, or if it's something that I can just answer right off the bat. Not worrying about the details here, an absolute value is a positive or possibly 0 number. So is it possible for a positive, again, or maybe 0 number to be less than or equal to 3? Yes, of course. That means we should continue and go on and work things. The difference would be that if we were asking, say that, where is this absolute value less than a negative number? Well, then the question is this positive thing smaller than this negative thing? And the answer is no. And I don't need to work anything out because it's just a question that doesn't really make sense to be asked in the first place. Here, though, because we're comparing to a positive number, we're good to go. We're going to jump in and sort of continue working. So 2 things that need to happen. 1, I need to solve the equation. And 2, I need to solve the inequality. So what I'm going to do is take this thing and let's go with purple. That seems like a nice choice. I'm going to replace the less than or equal to with just an equal sign and solve the equation. Equations are a little more concrete, a little easier to deal with. So I'm going to start by solving that. Again, don't worry about what's going on the inside here. For the absolute value of something to be equal to 3, that means it's either 3 or the opposite of 3 in the number line sense. So what I can do is decompose this into 2 separate statements. Either x minus 3, the stuff inside, dropping the absolute value bars, is equal to negative 3, or it's equal to 3. Then just solve those. and I get 0 and 6. What this tells me is that if x is 0, then I get the absolute value of -3, which is 3. If x is 6, I get the absolute value of 3, which is 3. So in the original inequality, that's, again, 3 equal to 3, right? So what we've just found is the points where these things actually intersect, where they meet, where they're exactly the same value. So we need these. These are important. What we're really trying to find, though, is not only the points where they're exactly the same, but the points where they're not exactly the same in a particular way, right? Where the thing on the left is smaller than the thing on the right. What I just learned, though, is the only possible values where that behavior can change. So what I'm going to do is draw myself a little x-axis here, just to kind of organize and keep track of stuff. I'm going to mark 0 and 6 because 0 and 6 are important at the values that we just found. That's where things can change. And what that means is that 0 and 6 take the entire x-axis, the whole real line, and cut it into 1, 2, 3 pieces, 3 intervals. On each of those intervals, either this inequality is true or it's false. Because those are the only options, right? And we know it's not equal on those intervals in between those two numbers. So this is either true or false. So all I'm going to do is decide which is which. There are a few ways to do that. I could think about it graphically. So the graph of this absolute value thing looks something like that. What we've just figured out is that it crosses through the height 3 at 0 and at 6. And then what we're looking for is where the absolute value is less than 3. Well, here it's sitting above, so it's greater than. Here it's sitting above, so it's greater than. So that would be this middle chunk. Another way to do that would be to just kind of brute force it. Choose a point from each of those subintervals, plug it into the inequality, and see what happens. So if x is -1, I'm going right here. The absolute value of -1 minus 3, that's the absolute value -4, which is 4. And then the question is 4 less than or equal to 3? And the answer is no. So I throw that interval out because anything on that interval, the same thing is going to happen. I'm going to get a false statement when I try to check that inequality. Do the other thing with these other two, or the same thing with these other two values. Absolute value -1 is 1. Is 1 less than or equal to 3? Yes. This interval is going to be included then in my solution set. And 7 minus 3 is 4. Is 4 is not less than 3. So I don't include that piece. So my solution set then, when this inequality is true, is because it's less than or equal to, so the endpoints are included. And then everything between 0 and 6, solution set looks like that then. In interval notation, that would be 0 to 6 with brackets to show that it's a closed interval or the endpoints are included. Okay, one more time, just kind of walking back through that. Solving the inequality, first I clean things up a little bit just so that I can kind of see more clearly what's going on and make sure that this is a place that I actually need to do some work and I can't just answer it already. Then, and this is how I'm going to solve any kind of inequality that we ever see. I'm going to do basically the same thing. Solve the equation first, then solve the inequality by either using some kind of graphical reasoning idea, right? The question was less than means sitting below. So not here, and not here, but in here works. Or by, you kind of like the numerical argument more, by testing points to decide which intervals work and which don't, and then just writing down the answer based on that. Okay, well, there's that. Please let me know if you have any questions, and I hope this helps.